Alright, in class we already started notes on momentum. This is mostly going to be a through a that connection to your book. We're talking about momentum equation, key components here. Have some practice problems that we class. The impulse and the impulse equation. Practice. Impulse changes momentum. Talk about how impulse and momentum interact with each other. We'll talk about all these terms and units that go along with it. And we'll talk through some examples and might have some examples. Right. One note, impulse and momentum, same title page, same introductory information. So momentum, impulse, changes in momentum. So already did in class. Tonight, this last one. This stuff, so start. Okay, so just in general, as time passes, of course, you guys know this. If I push on a car that's dead, I put it in neutral, and I push on the car for a minute versus I push on the car for 10 minutes, the car's going to start rolling. Depending on how much force you apply, the car will start rolling farther if you apply more time. Impulse looks at these components. So the actual definition of impulse, yes, is a measure of how much force is applied over a given period of time. And it's always equal to the change in momentum. So take the equation we just learned and piling them. So your force and time can affect momentum of an object. So if I push roll a bowling ball downhill, if I apply more force, it's going to move quicker. Alright, or if I push it for longer, it's going to. So an impulse is a force exerted to change the momentum of an object. Here we go. I is impulse, also sometimes referred to as J. Okay. Force, this is delta. Delta is change in. Adjustments change in time. Alright? Because you don't usually do something for milliseconds. Impulse is measured in Newton seconds. There are special terms here. It's just n-s or n multiplied by s seconds. Please note, if your force decreases but you increase your time, impulse will be the same as force is large and time is small. Okay. Here is a basic, this is just walking through how to plug and chug this, right? So if we get out and 2 newtons goes here, and we have 3 seconds. So change in time. Over 3 seconds, right? 6 seconds is the impulse. What's nice about this is this set of equal to just about velocity or the mass of the object. Right, so let's try. Take a moment, pause the video. Plug this. Okay, hopefully you pause the video. Here we go. Please pay attention to our units here. 15 newtons is in force. 3.45 seconds is in time. Multiply 52.85 newton seconds. That's an impulse, right? That again will help you calculate. Okay, now we're throwing you off here. Have 39.5 seconds. So it's going to go here instead of where you expect. Alright, seconds, not just this. Is here. So chug, you're going to have 39.5 time equals force times 16. Number good of F by itself. Now F stands alone, and you can calculate F is equal to 39.5 divided by 16. Great, easy idea here. Apply 10 newtons for 10 minutes. You apply 10 newtons of force to something for 10 minutes, and it's going to get moving. unless it's like refrigerator stop dead, super much friction, right? We're gating that. Or if I apply 10 minutes of force for 5 minutes, if I'm pushing on a car in neutral for 10 minutes versus a car for 5 minutes, it's going to make a dramatic difference. Okay? So converted those numbers to seconds. 600 seconds for 10 minutes, 300 seconds for 5 minutes. And they multiplied it. Obviously, the impulse is here, which will also increase the momentum. Okay, here's where these things go together. This force times time is equal to momentum, right? So increase momentum, increase impulse up. The greater the impulse, the greater the momentum. Okay? Impulse equals change in momentum. So I has two different components that'll work to solve depending on what the math or what numbers they give the equation. So pay close attention. Forget impulse is delta m, right? They didn't distribute correctly here. So if you distribute delta m, delta v. Usually your mass doesn't change. If mass changes, it would be like the rocket fuel being burned up, so your mass is going down. Right? So impulse is force times change in time, or change in mass times velocity. Impulse can be exerted to increase or decrease its momentum. So if something's already moving, I hit it from behind, it's going to continue forward. See that like in football, if you tackle somebody who's already forward, tackle behind, they're going to continue in that direction with decreased or increased momentum. This is just building what we're already. Okay, here are the full components. Pause and jot these down. Very important. Other units that not include is the kilogram times meters per second. Remember that is for P. This is for pulse. This is for just right, we're now saying, okay? Okay, so I wish that up the whole first thing you're going to need to realize is that you have to find all the components. So it's highlighted. 4.230 meters per second, 14.818 meters per second, 11.23 seconds, have 7.3. Alright, well we have 4 terms and 4 letters, so but if you notice, looking at the n component, their units have components here that are important. Meters per second, meters per second. This is going to help us calculate change of velocity. So let's go here. 14.18 meters per second minus 4.2 meters per second. Okay, so that one solved. 11 seconds goes here. 2 seconds. Then we have mass 7. Look, so we need to solve force. So we need to get rid of time by both sides by delta t. By t. Sorry, it's messy. I'm trying to do this without on a pen. All right. Force stands alone. Now we use all these numbers to solve. So don't forget the subtraction of 2 velocities, because it's a change in velocity. So we're trying to figure out the force at which these two things are hitting each other, or whatever. We talked about this before. If it's a small force that's acting long, it'll still slow down the car as effectively as if it's a quick force for a short time. The only difference would be a big force for a short time might crunch the front of the car, where slowly braking. So as you guys learn drive, slowly putting on your brakes, and slowing that brake. There's a lot less damage on the brakes. Okay. Another fine example. So in class I talked about with some of you, I took an egg and threw it at the wall. The impulse, the force of my throw hitting the wall instantaneously in a short time frame would cause that egg to break and shatter. But if I put in front of the wall, I hung up a sheet, let it hang, and threw an egg at the wall, the egg wouldn't crack until it rolled down the sheet to the floor. Why is that? I've increased the time of contact. The amount of time the egg contacted the sheet is increased. Same here. That is an egg, egg head, and think of this is my wall. It's practically a big old plastic wall versus a sheet filled with air. Still doesn't feel great with the impact of the force, but increases the time. So face and the steering less damage. The steering wheel is supposed to look like that. In another case, in sports, to increase your increase the force, shorten time. See the impact on the steering. Okay. Last example. Okay. Here again. See those big bumpers? They're supposed to increase the impact between the impact of the car and something damaging. So the foam is clouds, preventing your car from sustaining so much damage. So, another great example is batting in baseball. You can change your momentum a variety of ways. The mass obviously stays the same. We're talking the mass of the ball, all right? But velocity, the way you control the ball is the velocity of the bat, the speed at which you swing the bat. You increase the swing speed, increase your velocity, obviously, increasing the effect of the momentum of the ball. Also with the bats, if you change the weight of the bat, it's going to affect how much momentum you get in the swing. Right? So here, if you increase the weight of the bat, velocity is going to decrease, but mass will be affected. Right? Another example, bringing in other components, force versus time in ball. In baseball, either hit harder or you can follow through with the swing, continue contact with the ball. In this case, with this, you're following all the way through, increasing the contact while also increasing the force. While here, when you bunt the ball, you are not swinging hard the ball most of the time, you're just holding it up and taking the force of the ball against the bat. It also means the contact is decreased. Here's another example. It's very good. Off here. This is looking at have the impulse, and it's looking at the difference of contact time. So the amount of force you have to apply is less when you increase your contact. So, less into it when you follow through. That's what's so important. I always tell you to follow through. Thanks. That's it. Just a section.